Okay guys, so one of the classes I was able to let you know that I wouldn't be here today. The other class, well, this is a surprise. You're going to be working on systems of equations, the elimination method. It's a frog worksheet. On one side is the coloring, so if you finish all the equations, you can color it. I'm more worried that you know how to solve using systems of equations though, or using the elimination method. So we're going to take a look at a couple of examples of problems on that worksheet so that you can kind of refresh your brains. It's been since Thursday since we did the notes for this. So let's take a look. I wanted to go over number one. So an example like number one, we already are given exact opposites. You can see right here, we have a negative 3y and a positive 3y. Those are exact opposites, which is what we need to get these things to cancel and eliminate the y's. So we're going to go ahead, draw our equals line underneath and our plus so that we can add these two equations together. X plus x. Be very careful here. A lot of people want to write x. I have one x and another x. That gives me 2x. Negative 3y plus 3y, they cancel completely. There is no y left. Bring down the equal sign, and negative 5 plus 1 is negative 4. Now I have an equation I can solve. Divide both sides by 2, and we get x equals negative 2. Whenever we're solving a system, we need coordinates, x and y. I have the x, so I can go back to any equation, plug the negative 2 in for the x, write the rest of the equation, and solve for y. So I can add 2. Negative 3y equals negative 3. Divide both sides by negative 3. And we get y equals positive 1. So our solution is x comma y, negative 2 comma 1. And if you look at the sheet, that's saying that green is the correct answer. And if you were to color on the other side, that means every blank that has a 1 in it, you would color green. Okay, let's move on to another type of example. So I'm jumping to number 6, and I'm going to change the color here because I don't like that red on this. See how orange does. So if we look now at number 6, we don't have exact opposites. We have almost opposites in our x's and almost opposites in our y's. So that means that we can go ahead and multiply one of our equations to get the opposite of the other. I can either try to eliminate the x's first or the y's. Just because we did the y's last time, I'm going to do the x's this time to show you an example that way. So if we take a look, if I want to make my x's opposite, right now I have a 4 and a negative 8. Well, I can multiply 4. And again, I'm going to do the whole equation. I can't just multiply the 4. If I multiply that by 2, that'll give me positive 8, which is the exact opposite of negative 8. So I need to do that to everything in the equation, even the right side of that equal sign. So that's going to give me an 8x minus 6y equals 2. I can transfer over the second equation. Put a plus and an equal sign there. So 8x plus negative 8x takes them completely away. And look here, negative 6y plus 6y takes them completely away. It ends up them both being exact opposites. So I have no variables left. I just have a 0 over here. Bring down my equal sign. 2 plus negative 2, they cancel, giving me 0. So I have no variables left in the problem. I have 0 equals 0. When I have no variables left and I have a number equals a number, if it is a true statement, then it's going to be infinite solutions. And remember, we get infinite solutions when we're talking about the same line. If you were to go back to these equations and put them both into slope-intercept form, you would notice they're the exact same equation. They're the exact same line. That's why this one is infinite solutions. 0 does equal 0, that is true, so infinite solutions. Let me talk for a second. So the answer for number 6 is infinite solutions, which is going to be light green. Okay, I don't want you to get confused thinking the thing I do next is this answer. That's the answer for number 6. However, if we were to get rid of all the variables and get something that's not a true statement, like 0 equals 21, okay, that's false. That would be an example of something that would be a no solution. And again, we get no solution when the two lines are parallel. So if you wanted to double check that that's right, you could always put the original equations into slope-intercept form. If both of them have the exact same slope with different y-intercepts, that means that they're parallel lines, they'll never cross, so there would be a no solution. So I believe there is one answer that's going to be a no solution on this sheet. Again, number 6 is infinite solutions. I just wanted to show you another example so that you knew what to expect when you get there. All right, one more. Let's look at 14. So number 14, I have a negative and a positive with my x's. I have 2 negatives with the y's. So if I want to eliminate the y's, I'd have to multiply one of them by a negative number so that one of these turns positive. Or I can just multiply in the x's by 2 positives because they already have opposite signs. So I'm going to look, I want to eliminate my y's because when I'm looking, I know that I'm going to be dealing with smaller numbers, multiplying there. Again, you can do it with the x's, you're just going to be dealing with some bigger numbers to be multiplying. So in this case, I have to multiply both equations. If I'm looking at my y's, I have -5 and -4. I can't just multiply one equation to get the exact opposite of the other. So -5 and -4, I think least common denominator, that would be 20. So to turn 5 into 20, we would multiply it by 4. And to turn 4 into 20, I would multiply it by 5. And here again, we have the same signs. I need one of those to be the opposite sign, so I need to multiply one of them by a negative. Doesn't matter which one, but just one. So I'm going to multiply those all out, distribute everything to the first equation. So -4 times -9 is going to give us positive 36x. And then -4 times -5 gives us positive 20y. And then -4 times 26 is going to give us -104. And then I need to distribute to the bottom everything, even the other side of that equal sign. Don't forget about that. So then I have 20x minus 20y equals 5 times -24, -120. Put my equals, my plus, now I can add these together. So 36x plus 20x is 56x. 20y plus -20y eliminates our y's. Bring down my equal sign. -104 plus -120 is going to give us -224. And then we're going to divide both sides by our 56, solve this equation. We get x equals -4. And then we need to plug that back in to any equation. I can come back to one of the originals, or I can come to one of these. Now, these are bigger numbers, so I'm not sure why you'd want to do that, but you could. So I'm going to come back to, let me use the second equation this time. So 4 times -4, replacing the x. And then I'm going to multiply at -16 minus 4y equals -24. Then we're going to add 16. We get -4y equals -8. Divide both sides by -4. And we get y It's 2, so our solution should be -4, +2, which means orange is the correct answer for number 14. So we did 3 out of the 14. You can work on the rest of them. Whatever you do not finish during this period becomes your homework. Again, the coloring is not homework. The problems are. All 14 problems and work need to be shown for credit. Okay, guys, have a good day.